Okay, here we are. Hello everyone. Thank you for coming. Um, this is my talk about automating generative deep learning for computational creativity, and this is mostly based on a paper that we did together with Terence Broad, also iGGi student. I think I've seen him before. I don't know if he's around. Christian is a former iGGi student himself. He graduated, I think, last year, and now moved on to a postdoc position. And of course, Simon, who's a professor at Queen Mary. And we're going to present this paper as well at the International Conference on Computational Creativity next week. So if you're around, come by and say hello. So this is a short overview of the topics. So we're going to talk a little bit about generative deep learning and the visual arts, also touch lightly on automated machine learning. And that gives us the opportunity to talk a little bit about creative autonomy and computational creativity, and then also a little bit about human-computer co-creation in that context. So generative deep learning has seen a lot of interest in the art community and visual arts, and especially what then has been called gun artist. This is an example by Sofia Crespo. And these tools or these pipelines or machine learning models are mostly used as tools for these artists that allow them to generate very intriguing visual art and artifacts. And they include many manual tasks, both in generation and evaluation. And many of these decisions have an influence on the actual generated artifacts. So there's a lot of tweaking and going on, and people figure out their own pipelines and their own work is very dependent on having their own kind of setup. Then another topic that we brought on for this paper is automated machine learning. And this is really about automating the manual task in machine learning pipelines. More of a standard setup usually, so it's based around neural architecture search, optimization of hyperparameters. So it's really about optimizing the whole setup that you would use in your machine learning pipeline. And the goals are to decrease the manual workload and to make it a little bit more accessible for non-experts. And this is really driven by the demand for off-the-shelf solutions in industry, but also academia. And what automated machine learning really is automated decision making in the end. So, and now maybe you can already guess where we're going here. Then, of course, computational creativity is kind of the lens that we look at this. And here we have to take into consideration one of the central goals. I mean, there are many for sure, but one of the central ones is to endow a system with creative responsibilities and to thus increase the creative autonomy of such a computational system. So that was a simple idea to put these three together: generative deep learning and the visual arts and how it's used in the real world. Then this concept of automated machine learning, and the information that we got from 20 years of computational creativity research about autonomy. And these provide a lot of opportunities for more creatively autonomous systems through the automation of key tasks. And we developed a framework. So this is a standardized pipeline for generative deep learning in visual arts. We provide some targets for automation. So these are things that usually would be done by a person and could be automated, and thus provide an opportunity to hand over the creative responsibility to the generative system. And this is what the pipeline looks like as an overview. I'm going to go through it in detail in a second. What I want to highlight at this slide are the different stages that we have. So we have on one hand, we have the preparation stage, which is used to set up the system. I think someone has the microphone still on. Yes.
Okay.
At least I can hear you. Then we have the configuration stage, which is really setting up the system and defining all the configuration. And finally, we have the presentation stage, which is mostly evaluation deployment. So let's have a look at the targets, which are really the different choices and decisions that have to be made in the process. It's quite common to start with a pre-trained model in this art creation context, in order to build on the work of others, also because it's difficult to train a neural network. It can be expensive, so we can really build on what others have already created. This is entirely optional. You can start from scratch if you wanted to. But if you chose a pre-trained model, you might want to fine-tune it, so maybe diverge a little bit from the trained distribution. Or you might directly deploy it and choose not to fine-tune, in which case you would probably jump directly to model evaluation. And next step is data preparation and curation. So this is really something that you would do either for fine-tuning or if you start from scratch. This is about the acquisition, cleaning, and augmentation and transformation of data samples. And here we might consider different sources. So artists often have privately curated repositories, so image archives that are very specifically selected and kind of mark the style that they can then produce artworks in. A different source might be just a random internet scrape, and that can be very surprising if you don't even know what the machine kind of gathers together itself. The next 4 steps are kind of classic optimization problems in AutoML. I'm going to go through them real quickly. So network architecture, this is very similar to the network architecture search that I mentioned earlier, and also the training scheme selection. Then loss function definition. This is a little bit more something that we put in ourselves because usually we would try to optimize a neural network, and we might decide as an artist to kind of derail from that optimization, de-optimize it maybe. Then also the optimization algorithm selection, and of course the hyperparameter tuning. So these are things that are very classical topics in AutoML, but the artistic applications may differ from the standard applications in their goals and values. So as I said, it might be desirable to actively break a model in order to achieve a certain outcome. Artists might not be very interested in having the perfect optimized model, but are really interested in improving the output of their models. Then the training step, of course, this is the one thing that is fully automated by default, and it's what's usually done in artificial neural networks and other machine learning algorithms. This is the one step that, the machine just by itself, no human involvement required. And then when we have either one model or a set of models or different candidates or snapshots, we might want to select the best model, but and for that we need to evaluate it before we can finally deploy it, of course. And the question really is, what is the best here? So of course, in a standard pipeline, you would probably think that the one that has the least error or is the most efficient. But in an artistic context, could be just the one model that yields the most surprising output, or where the output meets other criteria. It could also be the one model that has the fastest inference time if you want to go for real-time generation, for example. And finally, we have output curation. And this is a step where you really want to increase the output quality, the overall output quality of the system. This could be done through filtering the generated artifacts. Could also be done through search, where we look for specific artifacts with a given criteria in the latent space of the model, for example. So having looked at these kind of opportunities for optimization, I want to switch to two perspectives that we can analyze this kind of framework. On the one hand, autonomous creative agency, and second, human-computer co-creativity. And Simon Colton himself, he described this as climbing the meta mountain. So this is mostly about creative autonomy. And Colton proposed to ask ourselves, what am I using the software for now? So what kind of choices do I take? What kind of creative tasks am I trying to solve? And once we identify these creative tasks that we are doing, we can write code that allows the software to use itself for the same purpose. And if we can do that repeatedly, ask ourselves, what am I using the software now? Answer that, and then code for these questions, the software will eventually create autonomously for a purpose, and with no human involvement. So here the idea is really that with each step that we automate, we take one step up the meta mountain, and this is equal to one step towards creative autonomy. But as I mentioned before, most of these pipelines or models are really used as a tool to help humans achieve their creative goals. And this is really then in the artistic settings can be really understood as a human-computer co-creative process. And here we rely on the definitions from Cantor Salo. I have the references later on the last slide. And here the artist and computational agent are working together towards a shared goal, and they define task-divided co-creativity and alternating co-creativity. And we have mapped these modes of human-computer co-creativity on a range from fully manual to fully automated. And the most extreme case, of course, autonomous creative systems, they take all the decisions themselves. All the decisions are automated. All the creative responsibilities really lie with the computational agent. Then we have task-divided co-creativity, where the human and the computational agent perform specific creative subtasks. So here really the responsibilities are divided, and the authors here, Cantor Salo and Toivonen, talk about incomplete agents. Then we have alternating co-creativity, and here the idea is that human and computational agents take turns in creating a new concept, satisfying the requirement of both parties. So human and the computational agent are really both much more involved in the process. So we have one thing that's really particular in using deep learning systems in this co-creativity setting, because they are themselves already self-adapting systems. And that means that they are, as we say, the machine learning pipeline without automation is already alternating co-creativity in a minimal sense. And this is really due to the loss functions that such a neural network uses, which essentially evaluates a generative process and does error correction, so it's kind of self-guided. So we also highlight the range of co-creativity modes that are achievable within our framework. And we also mention that the more tasks are being automated, the more the system becomes capable of co-creating with its user in an alternating fashion. So while the user's mode of interaction shifts, their agency remains stable. That essentially means that they become a little bit more of a director, a little bit more of a supervisor, maybe. They can still intervene at any stage, but of course, as the system kind of takes on creative responsibility itself, the kind of responsibilities also shift towards the system. So this is my brief overview. Thank you very much.